In this video, we'll look at the adjoint formula for an inverse matrix. The problem is to find A inverse using that adjoint formula. Well, the formula says that A inverse is equal to 1 over the determinant of A times a certain matrix called the adjoint of A. So let's do a little recap to see exactly how that adjoint is defined. The first idea we need is the idea of a cofactor. And a cofactor is a signed determinant. Now, when we say signed, we need to keep in mind that the sign pattern follows this checkerboard pattern. So the entry in the upper left gets a plus sign. As we move to the right or down, the signs alternate. So there's our sign pattern. Let's calculate the cofactor C11. So this refers to the entry in the first row and the first column in our matrix. Based on this position, the sign is positive. And so we're getting a positive 1 times the determinant that remains when we cross out the first row and the first column. So determinant of 8, 9, negative 1, negative 1, and that is equal to positive 1. Okay, let's try the cofactor C12. We're now talking about the entry in the first row and the second column, so that's this entry right here. Based on its position, it's going to have a negative sign. And we're getting negative 1 times the determinant that we get when we cross out the first row and now the second column. So 4, 9, 5, negative 1. All right, so that gives us a negative 1 times negative 4 minus 45 gives us negative 49. Got a double negative, so that gives us positive 49 for that particular cofactor. All right, let's try one more. Let's say we did the cofactor 2, 3. So we're talking about the entry in the second row and the third column. Based on that position, the sign is going to be negative. And then we're just getting the determinant that remains when we cross out that second row and that third column. I've just cleaned up our matrix A a little bit so that we can see the entries more clearly. Crossing out the second row and the third column, the determinant that remains is the determinant of negative 2, 3, 5, negative 1. So what we've got is negative 1 times minus 13, and that gives us positive 13. So we could go through and calculate all 9 cofactors using this rule that the cofactor is a signed determinant. What we want to do now is build the matrix of cofactors. So in the 1, 1 position, we're going to put the cofactor C11, that's 1. In the 1, 2 position, we'll put the cofactor 49. And we'll just fill in this matrix with the 9 cofactors. So it'd be great practice to go through and check all 9 of these cofactors. If you don't want to do that, maybe just select a few entries here and double check these cofactors. C23 was one of the ones that we already calculated. It was 13. And there we have all 9 cofactors for this matrix A. Now what we're working towards is this idea of the adjoint of a matrix. So let's write down the definition here. The adjoint of A is the matrix of cofactors transposed. So to get the adjoint of A, we're just interchanging the roles of the rows and columns, meaning we can copy the rows of this matrix into the columns and we'll have our adjoint. I've just recopied the original problem together with our formula for A inverse and the adjoint that we just calculated on the previous screen. So in order to apply this formula here for the inverse, the last thing we're going to need to do is calculate the determinant of A. So I suggest we do that by cofactor expansion. Let's expand along the top row here. We'd have minus 2 times the little 2 by 2 determinant that's left over when we cross out that row and column. And let's remember the checkerboard pattern for the sign. So as we move over to the 3, it's going to be minus 3 times the 2 by 2 determinant, 4, 9, 5, negative 1. And then finally plus 1 times the 2 by 2 determinant, 4, 8, 5, negative 1. So finishing off our calculation, we've got negative 2 times positive 1 minus 3 times negative 49, and then plus 1 times negative 44. So figuring out that sum, determinant of A comes out to 101. So now, applying our formula for A inverse, we can write down our final answer. A inverse is 1 over 101 times the adjoint of A, which is 1, 2, 19, 49, negative 3, 22, negative 44, 13, negative 28. And there we have our final answer for A inverse found using the adjoint of A.